In this video, we're going to go over the Lab 4 data calculations. On my right, I have my data sheet pulled up. Pull up one of yours. I'm using my cycle ergometer data. So if you want to follow along with that and then do it with your treadmill data afterwards, that works. If not, you can just still follow along, be able to get most of everything. You just need to make sure you have work rate here. Work rate is going to be 0 for everybody for rest, and then you need to start where you actually have speed and grade start going in. But again, this is from a different sheet, so make sure you just pull that in and input those values as input those values correctly. So we have VO2, VCO2, RER, and then we'll have to do a bunch of calculations here. We can see some of them already here on my left. We have for fat, a couple things for that, carbohydrates, a couple things, same thing as fats for it, exact energy expenditure, gross energy expenditure, and then there's a table below as well. One for work rate, VO2, coefficient of variation of VO2, RER, relative to VO2 max percentage, heat, how much heat is generated per minute in kcals per minute, gross mechanical efficiency, and net mechanical efficiency. So we're going to do a few things here. We'll start with the substrate utilization and energy expenditure part. So I'm just going to go ahead and get my table set up. I've already done a couple things here, such as minimizing the amount of what's available. So if you wanted to, you can come here and just be able to show less. Makes it look a little bit prettier, easier to look at. Because, I mean, you can see this has 15 digits past the right side of the decimal place. That's a lot. That's too much to look at. Go ahead and make things look a little bit prettier before getting started. I like to have 4 digits for RER, 3 for liters per minute on VO2, bike. No digits kind of works, but if you want 2 digits, that works as well. Then I also put my VO2 max in here. And that's just going to be from this table here. Make sure you put the appropriate one on the correct table so that you have it. We'll be referring to it later. Alright, so let's take a look. Let's dive into this. I'm just going to get mine set up more or less like so. My table set up like so. So fat and grams per minute, kcals per, and percent. Then this is going to be for those 3. And I'm just going to copy and paste that just because it's the same thing. Only now I need to change this to carbohydrates. Then we have exact energy expenditure, and that's going to be in kcals per minute. Gross energy expenditure, kcals per minute. So that takes care of that one. And let's do the bottom one. So this is work rate, watts, VO2, liters per minute, coefficient of variation of VO2, liters per minute, Jesus, percent, and then we have RER, relative to VO2 max, that's again percent. Now we have heat, how much heat is being generated by that exercise. This is stuff not going to useful work. This is chemical energy burned that is not going to useful work. And then gross mechanical efficiency, that's a percentage, and net mechanical efficiency, again a percentage. So this is everything we'll need. If you want to, you can get everything sort of straightened up. I'm just going to make this look a little bit prettier. Don't need to, it's just nice. Yeah, that'll work. That's plenty. Alright, so we can get started. We'll just start by filling out this table here. I'm working on table 3. If you're working on table 2, just make sure you put the correct data in the correct place. So we have our data on our right and our calculations on our left. You don't have to pull up the calculations if you don't want to. You can just follow along. So first we need to figure out how many grams of fat per minute am I using at each measurement time point. Now remember, we aren't always using fats. We're only using fats when it's basically less than 0.996 for RER. Anything above that, we're using all carbohydrates. And we're not using carbohydrates when we are below 0.7036 for RER. So again, we'll need to put those in, take those into account here. So to do that, we're going to do a if statement, if-then statement. So equals if RER is less than 0.996. So if that is true, perform the fat calculation, the grams per minute calculation. So 1.6946 times VO2, and then subtract that from 1.7012 times VCO2, close parenthesis. So that's if it's true. If it's false, 0. Close parenthesis. Again, if you need that real quick, there you go. All right, so this is definitely, the RER is above 0.996, so it should be 0. It's an easy check for me, at least. If yours is less than 0.996, you should see something. And if you're wondering where that 0.996 came from, it came from here. So 0.996 or above, it's 100% carbohydrates. If it's less than 0.7036, assume all fat. So we'll go back to our calculations. So here we can just double click, and we can make this again look a little bit prettier. 3 decimal places works well for this because these are small numbers at 0 point something, so we can, 3 decimal places works. It's about the size of the grams per minute, so it works. Now, kcal's of fat. Here, you might have used grams and multiplied by 9 before in another class, maybe in nutrition or anything like that. However, we want something that's a little bit more exact and at physiological levels. So at physiological levels, it's about 9.746. So we're going to just take our grams per minute and multiply by 9.746. Again, precision counts here, so we want to make sure we're as precise as we can. We don't want any rounding errors. I'll just do 2 decimal places. If you want 3, that's fine. It's just, it looks prettier. Don't want to put in all of those digits is the main thing. Now for percentage, we're going to do fat divided by the sum of fat and carbohydrates. We haven't done that part yet, but we can type this in, no problem. So equals, we'll point to our fat kcals per minute divided by parenthesis fat kcals per minute plus carbohydrates. You can't see it over here. I'm just going to go to the side. There we go. And multiply by 100. And here at the start, we're just going to get a divide by 0. That's expected because this 0 is actually in a 0. That's what I get. You may not get that. But I can still go down nonetheless. And, well, we don't have anything over here, so it's just going to be this number divided by this number, which equals 100. So easy enough. Now we need carbohydrates. So carbohydrates, we're going to then again do another if-then statement. So equals if RER is less than 0.7036, then if it's greater than 0.7036, then if that's true, then perform this calculation. Sorry, I'm glad I cut myself. It's greater than, not less than. If it's greater than 0.7036, then perform this calculation, which is 4.585 times VCO2 minus 3.2255 times VO2. And if that is false, 0, close parenthesis. And for mine, every single one is above that, so I should have some carbohydrates always being utilized. And in this case, this is 100%, or all of it is, all of my energy expenditure is assumed to be for non-protein related calculations, 100% that. We'll get rid of some of these decimals and all the way down. Now, we need to figure out how many kcals per minute this is. To do that, you might have used this as just a multiply by 4 before. Again, we want to be as precise as we can. We want to be as precise as we can. And from previous research, it's a mixture of things. It's not always one thing or another. And at physiological levels and the types of things that are actually metabolized in the body, they found it's about, I'm not going to go over the entire mixture, but it's about 3.8683 kcals. Again, precision matters in this stuff. We can't just round off and say, oh, it's 4, you know, for these types of calculations. In a shorthand calculation, you can, but this is not shorthand. We're not doing that. So 3.8683. 3.8683. Great. Let's shorten that up. Okay. And go down. And we can see this already populated. Perfect. I'll just go down to, go down to 2 decimal places because some of them have 2 on the left. Great. So we can see it goes up pretty generally, especially up towards steady state. It looks like it drops at stage changes and then goes back up. Kind of interesting. Now we need to figure out our last percentage. So equals, we do carbohydrates divided by, again, that sum. So fats plus that times 100. Okay. Alternatively, I could have instead done just whatever this percentage, 100% minus this is. I could have done that. That would get you the same answer, but close enough. Either way works. Awesome. You can see each of these adds up to 100. We don't have any rounding errors in there. Awesome. Yep. That's the benefit of this precision. We want to make sure we don't have any rounding errors in here. So if we use like 4, we would have some really bad rounding errors. We want to make sure we use exactly these numbers. Okay, continuing on. Exact energy expenditure. That's just the kcals of energy that we've already calculated from fats and carbohydrates added together. Easy enough. So just these 2 things added together. Perfect. Gross energy expenditure is just VO2 multiplied by 5. It's a shorthand calculation. Gets us pretty close, but it cannot tell us how much of what fuel is being utilized or used or anything like that. It just gets you an approximation. So that concludes most of Table 2 or Table 3. Wrong thing. Table 2 or Table 3, whichever one you're doing. I'm doing Table 3. I just need to do some sums. And I'm going to do sum of VO2, VCO2, grams per minute of fat, kcals per minute of fat. Same thing for carbohydrates and exact energy expenditure. So we'll do that real quick. Sum. Just make sure you're doing that whole column, or that whole data set there. Just copy, paste, 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 paste. All right, so this is saying in that 30 minutes where I did rest and some stages of exercise, I consumed and used 36.136 liters of O2 and about 33 liters of CO2. Expired, at least. I didn't consume. I expired that much. And then fat, I used 5.254 grams of fat. And that's equivalent to about 51.209 kcals per minute. Or sorry, kcals, sorry, not kcals per minute, kcals. And for carbohydrates, it's about 34.686 grams. And carbohydrates, kcals per minute, kcals, that's about 134 kcals of that. So this is kind of interesting. You get to look at, it's not usually presented in this fashion, but this gives you an idea of, oh, this is how much fat I used, and this is how much carbohydrates I used. It gives you an idea of, oh, like a food label. You could just look at a food label and say, oh, I did 5 grams, 5.254 grams of fat and 34.686. You know, that's kind of cool. So hope you found that interesting. And then exact energy expenditure, 185.387 gross, 180.682 for me at least. So a little bit higher for exact versus gross, and that matters a little bit, but it's pretty close, but again, with gross energy expenditure, you could not get these sorts of pieces of information. You would have to make a lot of assumptions, and those assumptions would have a lot of error to them. Some amount of error, sometimes more than others. So that concludes Table 3 for me, or Table 2 for you, so make sure you do the other one appropriately. Continuing on, we'll go ahead to Table 4 or Table 5, whichever one you're working on. I'm working on Table 5. Here, we're going to start at minute 10. So minute 10, and I'm going to start at minute 12, make it a little bit easier. We're going to do a few averages. So in here, average. We're going to do average VO2. Oh, sorry, not VO2, work rate. Now you got 2 work rates to choose from for a cycle ergometer. Make sure you choose either work rate R, work R, or bike measured. Don't use load program. You can see what is programmed right at about minute 7, or 4 minutes 7 is 28, but I, or your subject, had to pedal a little bit during that period. It's not started right off the bat. So make sure you do use the proper minute 10 to 11, either work R. If you're using treadmill, it's going to be work R that you inputted. Or for the bike, you can either use work R or bike measured. Okay. Let's make this simple. We can just copy this and go down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 6 minutes, so that's why I was counting 6. Easy enough. So 28 to 29. And so on. 22 to 24, which is exactly what we need. Awesome. Then we have VO2. This one was the one I almost did the first time. Again, an average VO2. Just paste at the same levels again. And that makes sense. My VO2, or the person's VO2, should increase while doing this. Coefficient of variation you may have a passing familiarity with, maybe none, but coefficient of variation tells us how much dispersion there is in a unitless fashion around the mean. It's usually very good measure, especially when numbers are not so close to 0. When they're close to 0, you may want a larger dispersion than at higher numbers, just because a 0 mean doesn't have much variation that can happen. In anything that can be 0. VO2 can be 0, or if it was 0, you wouldn't be alive. But but if it got that low, it can't be negative, so to speak. At least usage cannot be negative. We're not outputting CO2, so we're not outputting O2 in the air. So with this, we need to do it based on standard deviation of our sample divided by our mean of O2 multiplied by 100. So equals standard, or ST deviation, ST dev, dot S We're doing sample, not population. This is sample. Go over to VO2, close that, then we'll divide by our average. We already calculated the average. Already calculated that average. Not bad. And then multiply by 100. Let's calm it down there with those numbers. 2 decimal places, 3 decimal places works. Alright, 0.374, 8.68 for me, and 8.53, and then 3.42. So, generally acceptable. Like, what's good? What's good for this? You know, less than or equal to 5%. That's pretty good. 10 can be okay, depends on what you're doing. If it's close to 0, as I said, it could be, that's usually acceptable. Like right about here. You don't have to do this, I'm just doing this for brevity's sake. Here's where my resting was, and it's pretty close to 0, so it's going to have very little variation that can happen in there, and those tiny deviations are magnified more. So I could accept this, just because resting is going to be so, with its smaller deviations, can be quite variable. But exercise should not be as variable. So these are less than, they're maybe, I'd say if it was my data in a research study, this would be not acceptable. And this is my data actually being performed on me. So I'm saying I would not have been a good fit for doing this. I would not accept this if it was a research study. Class data is okay. We want to use class data to learn from. And I didn't do this on purpose either. This is just how it occurred. But this sort of thing tells me there might have been some, my work rate was fine. My work rate was fine the entire time, but there could have been some problem with how much I was breathing in and out, or how fast I was breathing. Maybe I was taking a little bit shallower breaths and breathing faster, breaths per minute, and taking shorter breaths, so less tidal volume. I need some outside data to look at that. One other sign for my data, at least, is I was pedaling a little bit faster than I probably needed to be. I'm not a trained cyclist, so this is faster than I should probably be pedaling. And so there could be some mechanical inefficiencies in that, which then show up in your breathing data, or at least would show up in my breathing data as measured by pressure, tidal volume, and respiration rate. But we don't have that information exported here to look at. Let's continue on though. So RER, what's kind of cool is I'm just going to highlight these, copy, paste. And those are RER values. If you want to verify, you can just click on one of them, scroll over, and see, oh yeah, this is on RER for that minute 10 to 12. So this is the other sign that tells me, oh yeah, there was something going on with my breathing without the other data. Here we have 0.8621, and then bump up in work rate, 0.9121, and then another bump up, oh, it drops for me, 0.8800. That is not expected. So that tells me there is something going on with my breathing. That's a very clear sign something is going on with it. And if I wanted to investigate further, I could, but we're not going to do that here. We don't have the data at hand exported. I have to go back to the computer and do that. But stage 1 and stage 4 are fine for me, but yeah, that middle stage, those middle two stages are kind of wonky for me. My breathing was weird. Probably a little bit of hyperventilation in there. Hyperventilation is in breathing really fast, shallow breaths. Alright, so now let's move on to percentage of VO2 max. So for this one, equals, we need to point to what our VO2 was during this time frame and divide it by our VO2 max, or our person's VO2 max. Here, I put it over here, and before I finish it out, I'm going to put a $sign in here and then multiply by 100. Okay, let's calm down with those numbers there. All right, I was at 28.23. Now, since I put that $sign in, I can just copy and paste down below. So I increased from 28.23 to 36.45 to 50.18 to 57.94. So about 8%, give or take, per bump. Close, but you know, there's a little bit of a wonkiness in here, possibly within especially this one. I would say maybe it started in here in stage 2, but it was for sure in stage 3 as well. But okay, heat. This one's a little bit different. This is all energy that was used or consumed, but not put towards useful work. All chemical energy that was not put towards useful work. So for this, we're going to take our chemical energy, which was VO2, or sorry, not VO2, which was exact energy expenditure, subtract it from mechanical energy, which is work rate. Work rate we need to get from watts to kcals per minute though, so we need to do one calculation for that. So equals, we'll point to, we're going to do the average during that period, energy expenditure, and we'll subtract it from our work rate and divide it by one thing. I'll go back just so you can see it, 69.78. We'll divide that by 69.78. And here, at about 4.371 kcals per minute. So you can see, here's my exact energy expenditure. Here's how many kcals heat. That's, you know, about just shy of 0.5 was actually put towards 0.5 kcals per minute was put towards useful work. There's a lot of inefficiency in there. And then we can copy and paste that, copy and paste, copy and paste. We can see lots and lots of changes, how much was put towards useful work. Double check. Yep, we're good, we're good. All right. Now we need to do gross mechanical efficiency. All right, so this one we'll do equals. We need to get our work rate into kcals per minute, because we're going to divide it by kcals per minute rather than subtracting like we did here to find heat. We're just going to divide them out. We're going to divide them out, and it's energy required for work rate divided by energy used, exact energy expenditure. So convert this 69.78 and then divide that by exact energy expenditure, but we need the average. Oops. Average. And then multiply by 100. Okay. A little bit prettier looking. We don't need any $signs. We can just multiply and go through. Oh, sorry, copy and paste and go through. All right, so my gross mechanical efficiency, 8.41 to 12.66, 13.96 during that weird period of breathing, and then 15.45. Now, if you're wondering, oh, that seems low still, the 20 to 25% for a cycle ergometer is more akin to net mechanical efficiency, not gross mechanical efficiency. So let's take a look at net mechanical efficiency. So equals, this is going to be very similar. So equals, actually you could just, we can start by copying this. Start by copying that, but before you hit return, what we'll do is we're going to put that denominator in some parentheses, and inside we're going to subtract out the average of resting energy expenditure, resting energy expenditure, subtracting that out from our current work rate energy expenditure. And before I hit return on that or enter, I'm going to put dollar signs. Whoops, dollar signs on that. Okay. And let's go down to 2. The reason I put dollar signs, because if I copied and pasted this, if I did it from here, it would be pointing up towards here, and I'd actually get, I think, a negative number, or a really wonky number. Get a really wonky number. So, here's another sign that I was probably pedaling very inefficiently, was I never got up to that 20 to 25%. So there's pedaling inefficiency in terms of my RPM, and you can see my RPM was, especially at the end, was upwards of 100. I'm not a cyclist. I should not be pedaling at 100. I was. Ideally 60 to 80 for non-cyclist. But still, and another clear sign, my net mechanical efficiency went down. Again, with that breathing strangeness, I was breathing and pedaling inefficiently. I could still do it, but it just wasn't very good. Very good. Again, I'm not a cyclist. See if any of your data looks a little wonky. Any of your class data looks a little wonky. This is interesting stuff. You have to learn something, what's going on. You can't just always take it at face value. All right, so this concludes. Whoops, went back to the same thing I showed you again. That's not one of your assignments, don't worry. So, taking a look at this, we have completed one of our table 4 or table 5, so you need to complete your other table. However, this concludes the video, and if you have any questions, please reach out to your instructor or myself. Stay healthy, and I will see you in the next video.